Okay. Okay, let us continue the discussion. We were discussing about the dot product and the cross product. As a note I have written here, you just please go through it. Dot product, if we want to write in terms of rectangular coordinates, how we can write it? Consider A is equal to C. Observe, in the previous session, I have used I, J, K as the unit vectors. Here, I have used AX, AY, AZ. Remember, okay, you should be familiar with these terms. If you represent A and B vectors as AX, AY, AZ are the three different magnitudes of this A in three different directions, X, Y, and Z. Similarly, B stands for a vector which has got three different magnitude values, components, Bx, By, Bz in X, Y, Z direction. If you want to take the dot product of this A dot B, just try to multiply these two. What you will get? What you have to do is take this first term, multiply it with all the three that I have written here, first term, second term, and third term. This is I got when I multiply this first term with this first, you can check AX, BX, then AX into AX. This is the first term. Then second term, this is your second term. Then this is your third term. Likewise, each term should be multiplied with three terms. So 3 into 3, you will get 9 different terms. So this is first, this is second set of 3, third set of 3. Please try to multiply this. I will not go into it. Then after multiplying, you will get 9 different terms. Out of 9 different terms, we will make use of certain identities of dot products. Dot product, just now we have seen it. If it is I dot I, it is equal to 1. But if it is I dot j, it will be 0 because theta angle will be 0, right? Theta angle will be 90 degree, cos 90 will become 0. So I have checked marked here, only 3 terms will remain because it is with the same I dot I, AX dot AX, AY dot AY, AZ dot AZ, remaining all will vanish. So this is your dot product of two vectors. Similarly, taking the cross product, I have taken the same A and B. If I want to take the cross product, just multiply it. Again, you will get 9 different terms. How to take the multiplication? Take this first term, multiply it with 1, 2, and 3. So for that, you will get these 3 terms. Similarly, second and third, 3 into 3, 9 terms you will get. Again, out of 9 terms, only 6 terms will remain, 3 terms will vanish. How? We'll see. This is I cross I. I cross I is angle theta is 0, sine 0 will be 0. So these 3 terms, AX cross AX, AY cross AY, AZ cross AZ, these 3 terms will vanish. Remaining, you will be getting 6 different terms I have listed here. These 6 terms I have listed here, and if anything is common, say AZ you have got 2 terms, AY you have got 2 terms, and AZ you have 2 terms. So I have taken common AX, AY, and AZ 2 terms. Then can we represent this in any short form? Yes, we can. The cross product is, in short, calculated. It can be calculated using the determinant. Whatever this equation we have got, we can present this in this form. You try to expand this, you try to calculate the determinant, you will get this equation back. Okay, in short, cross product can be written in this determinant form. I hope you remember this, how to calculate the determinant. Now we have one problem here. Let's try a simple problem. I know these are not at all your syllabus. Okay, please don't feel that this is not in your syllabus, so we should not study this. All these are the basics. If you know these basics thoroughly, you know electromagnetics, the actual concepts what you're going to study, they'll become very easy for you to understand. Okay, with this example, let us try to find. If you observe the question, the three vertices of a triangle are given to you, A, B and C. This is the triangle given. You have to find this R is your distance vector, RAB between these two, cross RAC. So cross product you need to find out. So to get the cross product, you should have what? Two vectors, right? Two vectors if you have, you can calculate the cross product. These two vectors you should have. Then the area of the triangle and the unit vector. How to find the cross product? Point A is given to you. So A vector you can write it 6i minus 1j plus 2k. This is A. Then B vector, point is given to you. So write the vector minus 2i plus 3j minus 4k. And the C point is given to you, write the C vector. So how to go through this? In order to find the cross product, we want RAB, this distance we want. How to find this distance? Use the distance formula. A and B points are given to you. Okay, RAB equals to B vector minus A vector. This is a very known fact to you. Just let me recall it. Yeah. If any vector is there, RPQ, you write RQ minus RP. Whatever suffix, second suffix is there, that value minus the first suffix. So here also, let us take that. RAB, it is the second suffix minus first suffix, B minus A. So B is here, A is here. Take minus 2, minus 6, then plus 3, minus 1, minus 4, minus 2. So you will get this first vector. Then find RAC. Again take C minus A. C is here, A is here. That is minus 3, minus 6, plus 1. What is this? Plus 1, plus 1, 2 times, right? Minus of minus. Then plus 5, minus 2. You will get this. So two vectors RAB and RAC you have got. Now you can calculate the cross product. It is the cross product. Take this ijk, first vector coefficients, second vector coefficients, calculate it, you will get this. I hope you know how to calculate the determinant. If you don't know, please ask me, I'll solve it. Else I'll continue. You know how to calculate the determinant, right? Now the next question is, you need to find the area of the triangle. Area in terms of cross product, this is the formula. Half of the cross, any two sides value. This two sides just now cross product you have found out already. Okay, using the determinant. Take the magnitude of the answer. Magnitude means the square root of 24 square plus 78 square plus 20 square. This answer, whatever you get, this is your magnitude value of the cross product. Once you get the cross product magnitude, take half of that. That will be the area of the triangle. This is the formula for area of triangle. I think you know it. Half of any two sides length multiplication will give you the area. Then last one, unit vector. How to find the unit vector? You know this. The given vector divided by its magnitude. Vector, just now you have calculated this cross product of RAB and RAC. This is the vector. So take that vector as it is divided by the magnitude. For magnitude, just now you have calculated the magnitude. This is your unit vector. Split this. 24 divided by 84 plus 78 divided by 84 plus 20 divided by 84. Whatever coefficients you get, you write them. I hope you understood till this. Any doubts? We have completed dot product, cross product, some properties of both dot and cross product, some example, how to find the area of the triangle and the unit vector. So let us start with the new concept, that is del operator. This del operator you are going to use in your electromagnetics concepts. Okay, let us see what it is. What is this? I am writing something on the screen. What are these? I have circled it. What are these? Anyone? I hope you are there in the class. Or simply you have unmuted and, sorry. Arithmetic operators, very good. So they are the operators, right? If I write, if I take a sign like this, you know that it is an operator for which it indicates that we should add the things. This is division. Likewise, they are the operators. You know what to do with that, right? Similarly, similar to these things, del, that is the inverted triangle, that too with the arrow mark. This is one operator which we use in vector algebra or vector calculus. It plays a very important role individually, just like plus, minus, multiplication, division. Individually it doesn't have any meaning. Okay, it has to be associated with something, then only it has a meaning. So del, or the symbol is called nebula. Nebula operator, it is a vector, of course. The sign indicates it's a vector, and it is a differential operator. Okay, differential means you should have this d by dx form. Okay, it is a differential operator represented by this symbol, nebula operator, del. Okay, it is not a specific operator, just like plus, minus, multiplication and division. It is not a specific operator. Separately, it doesn't have any meaning by itself. So it has to be associated with either scalar or a vector. In order to get that, okay, I have made a chart for your simplicity. You can go through it. Just a second. If you check this chart, I have written here del, it is a vector and differential operator. Differential means that too partial, three different, in any coordinate system, we have got three different coordinates, x, y, z. So for a rectangular, it is dou by dou x. Dou because three different, so at any point of time, only one is the derivative. So dou by dou x, dou by dou y, dou by dou z. It is not a d by dx. It is dou by partial derivative. Okay, so if you associate a del operator with either scalar or a vector, if you associate del with scalar, it is called a gradient. Okay, and it is denoted as del v. Okay, don't take this dot. Okay, it is not dot. You have to simply write it like this, del v. That's it. This is called gradient. Okay, del operator applied on a scalar, we call it gradient. And when we apply this gradient on a scalar, the answer what we get, it is a vector field. Okay, application is on scalar, but answer we get is vector. And what is this v? Okay, del v I said. V is, we have assumed that v is denoting some scalar field, just like what? Scalar, temperature of ice cube in a container. So v is one such a scalar field quantity. Okay, Then del V is called the gradient. Then if you apply the del operator on a vector, we know that in case of vector, we have two different possibilities of multiplication, dot product or a cross product. So for vector, again, if you use del operator with vector, either we can use dot product or a cross product. If you're using the dot product, it is called divergence. So del dot product dot V, it is applicable on a vector. Hence, V here is a vector field. Here it was scalar field. Here in this first half, when we were using it on scalar, V whatever we have taken, we have assumed it as a scalar quantity, scalar field quantity. But when we are associating it with a vector, V is denoting a vector quantity. Again in vector, if we are using it in terms of dot product, it is called divergence, del dot V. Del dot V, or in short div indicates divergence of V. Okay, and this is a special case. This divergence, if the answer you get it 0, we call it solenoidal vector. And if del operator is used with vector, that too cross product, we call it curl of V or del cross V. See, del dot V and del cross V, divergence and curl. And if this curl is equal to 0, it is the meaning that irrotational vector. It is called irrotational vector. So there are basically three terms associated with del. Del separately, just like plus minus, it doesn't have any identity. It is a differential operator, partial, dou by dou x, dou by dou y, dou by dou z. Three terms come into picture: gradient, divergence, and a curl. Gradient means del is, we are operating on a scalar quantity, and if you're applying del on a vector quantity, if it is a dot product, it is divergence. If it is a cross product, it is a curl. Okay, this is the classification how we can use del operator. In short, I've written here, gradient we apply on a scalar. Answer you get is a vector. That's what I have written here. Gradient of a scalar is vector. Then divergence, dot product we apply. It is applied on a vector. Answer is a scalar. See, scalar to vector, vector to scalar. Then curl, we apply it on a vector. Answer is vector itself. In short, points to remember, I have written it. All these three things, gradient, divergence, and curl, I have written here in detail. What is the equation for each one? First, let's see what is the gradient of a scalar. Let's consider V, capital V is a scalar field. Then the equation del V is equal to, del is what? Dou by dou x, dou by dou y, dou by dou z is del. If you take for V, it will be V inside, just multiply. Okay, V will be inside, and AX, AY, and AZ are the three different coordinates. So this is called the del V. This equation, what I have written in the box, it is the gradient of V, and the gradient of the scalar will give you a vector quantity. This is about the gradient. Coming to the divergence. For divergence, I said in this chart, see, when del is operated on scalar, it is gradient. It should be operated on vector, either dot or cross, it is either divergence or a curl. So for divergence, it should be vector, dot product. So if we denote a vector field, then suppose we have three different coordinate values, then divergence of V or del dot product of V, it is equal to dou by dou x, dou by dou y, dou by dou z into, that is the dot product up to v, that is v is your vx, vy and vz. And for this dou by dou x, what is del actually? Del is this, which is having three different ax, ay, az. But here also you have ax, ay, az. When you are applying the dot product, what is I dot I? It is equal to 1, right? Because cos of 0, angle is 0. So cos 0 will be 1. So if you just take the dot product, here I have written it directly. You have to just take the dot product, multiply, you will get this. This box, whatever I have written, this is your divergence. So divergence of a vector is scalars, river. Then this is one new term to you, Laplacian. In the chart, we have seen gradient, divergence and curl, right? Now, if we apply, you can see in Laplace what we do. In Laplacian, we apply divergence for this, divergence of gradient. Whatever answer we got in gradient, for this, we are applying this concept. Because whatever answer we get here, it is a vector quantity. And for this vector, we will apply the divergence. Condition for divergence is what? It should be a vector. But when we are operating on scalar initially, for gradient, we get finally answer vector. So for this vector, we will apply divergence. So these two, gradient and divergence concept, when we club together, we will get Laplacian. Check. If we represents a scalar field initially, okay, and we got this already, it is a gradient. Del v is equal to this. It is a gradient. When we take the divergence for this, because whatever answer we get here, it is a vector. So for this vector, we will apply the divergence. Divergence is what? Del dot product of the quantity. Quantity is what? This. Okay. Then, so del is your dou by dou x, dou by dou y, dou by dou z, and already we have got this. So apply that, substitute that. Okay. And the LHS, you understood this? Del dot. Del is dou by dou x, dou by dou y, dou by dou z. And this already we have got this. So whatever this values are there, just apply this to these partial derivatives. Then what is dou by dou x of dou by dou x of dou by dou x? That is square you will get, right? Square of. Here also square of, here also square of. That's what I have written here finally. And it is in general V in all the three directions. This square box, this is called the Laplacian. If you just observe at the LHS, I have simply taken this as a square. Okay. This del square is called the Laplacian operator. If it is simply del, it is a del operator. It is del square, it is Laplacian operator. Coming to the next, curl. Okay. For curl, again the condition in the chart you have seen, it should be a vector quantity. So curl, that is del cross product, del cross of V. We have already seen this. Cross product can be written in the determinant form, ax, ay, az or ijk. Then del value, the first value, it is del dou by dou x, dou by dou y, dou by z, dou z. And next line, it is V value, Vx, Vy, Vz. This is the curl. In short, just remember this. So del operator individually, it doesn't have any meaning, just like plus minus. It should be associated with either scalar or a vector. If it is associated with the scalar quantity, then we call it divergence. Condition is it should be a scalar field. If you associate del with vector, two possibilities, dot or cross product. If it is applicable on dot product, we call it divergence. If it is applicable with a vector cross product, we call it curl. And simply del is a del operator, nebula, and if it is del square, it is Laplacian. Okay. Separately, gradient, if you apply on a scalar field, you will get vector. Now, divergence condition is it should be applied on a vector. Hence, whatever answer you get here for gradient, for this you apply whatever answer you get in the first, you apply that. This is your gradient value. For this, you apply the divergence dot product. You will get a del square, that is Laplacian. So I hope you understood these 3 points. Still, how much time is remaining? Can anybody tell? The next is, now we are still, about to come to this, our topics. The static electric field. Okay. What is a static electric field? It is, static means at rest. So electric field, whenever the term electric field comes, it is associated with a charge. Okay. Atom structure, imagine atom has got different charges. So whenever a field exists around the charges, that we call it electric field, and static means at rest. So the static electric field means charges at rest. So what is charging actually? We say that charging is a process. Okay. So charging is what? Addition or removal of the electrons. Okay. Either addition or removal, that is called the charging process in general. So in a normal atom, we know it's already, even our human body, we are neutral in nature, because the amount of the electrons and the neutrons, the protons, the positive charge, they are what? Balanced. So we are neutral in nature. In normal atom, which is electrically neutral, the total number of negative charges, that is electrons, orbital electrons, they are balanced by the total positive charges, that is protons in the nucleus. That's why it is balanced. We are neutral. If by any means these valence electrons, their orbit in the different orbits, they are revolving, if they are removed, then removal means, don't think that negative sign, it is positively charged. If any this if you have any atom with some plus sign, it indicates a removal of atom, removal of electron. A plus means, don't think that addition means kuch add hua hai, something has been added. No, A plus indicates removal, some electrons have been removed. And likewise, if electrons are added, it means it is like this. Negative means, don't think that it is deficient, kuch kam hai. A minus means the electrons are added, so it is negatively charged. There are basically 3 methods of charging. Charging by friction, conduction, or induction. 3 different methods are there. I think you have studied this already. I think friction, you have even done the experiment when you rub the rods. Even when you are sitting on a plastic chair, you might have felt that sometimes you get a shock. Okay, your hairs get stand, खड़े हो जाते हैं. So there are basically 3 methods of charging. Friction, okay, ek dusre se two bodies are rubbed together, that is friction. Conduction and induction, I'll not go into detail of those. Now, what is an electric charge and electric field? The space or the region around an electric charge in which that effect of charge is felt, we call it electric field. You know this, electrostatic field, charges at rest and a charge, the region around the charge, some effect is felt of that particular charge, we call it electric field. Okay, it may be due to either positive charge or a negative charge. Okay, and the presence or absence of electric field in a region, how can we define, how can we determine that the field is present? By bringing a test charge into that region. Okay, suppose that you have a charge, it is just like, suppose you have a magnet placed somewhere. Now to just know the effect of that magnet, you take one more material, okay, testing material near to it, just like that, in order to just check the presence of the electric field. You will take a test charge into that particular region. If that test charge experiences a force, we don't know, if they are like charges, they'll repel. If they are unlike charges, they'll attract. So that force depends on what kind of charges both are having, so that it will experience a force. So if it experiences a force, some deflection occurs. Okay, either it will get attracted or something, repulsion. So then this will confirm the presence of the field. This is one experiment, okay, kind of thing, just to know whether the field is electric field is present or not. Okay, and you know this already, I guess, the electrostatic field, how you can visualize the field. If it is a positive charge, the field lines, they start from the charge and they diverge. This is the convention used for positive charge, and for negative charge, they come and they converge. Okay, these are the conventions used for the lines of force, field lines or the flux lines. Okay, for positive charge, they diverge. For negative charge, they converge. These are the methods of charging. I'll share the document with you. You can please go through this document. I have taken this from the internet. Three different methods of charging. The details with the example, it's been given here. You can please read it, how the experiments have been done for all these three different methods. Okay. Then comes this. I think you have already seen this. If two charges of opposite polarity are placed near, this is the pattern. Positive means what? They diverge. Negative, they converge. If they are together, obviously there is a force of attraction, so they try to move. Why the direction is like this? Only because from positive it will start, diverge, it will converge at the negative. So the direction is like this, positive to start, negative पे end होता है आगे. Similarly, if two same polarities are kept of the same polarity, either positive or negative, see here, they both are positive, so they are diverging, okay, going out in both. But near this touching region, the space in between them, which is close, see, they are moving out. They are not coming like this. They are moving out from each other. Okay, this is the convention. Then field lines, positive means diverging, negative means converging on a surface. Okay. Two laws of electrostatics. One is like charges repel, unlike charges attract each other. You know this already from the childhood, you have been learning this. And the second law of electrostatics is Coulomb's inverse square law. I think now with this we have come to module 1. Coulomb's law and electric field intensity. The very first topic is experimental law of Coulomb. So we will start with the experimental law of Coulomb in the next session. I hope you have understood till today's session. Thank you so much.